Welcome to myprojectbazaar.com. Let we discuss about the process unsupervised SAR image change detection based on shift key points and region information. Let me see the abstract of the process unsupervised SAR image change detection based on shift key points and region information. The satellite images were main source for the identification of the resources. The analysis of the forest resources were helpful in the identification of the reliable sources. The differences in the regions can be identified by segmentation of the images and comparison of the segmented portions in the images. The segmentation process is done based on point extraction, which is done using SHIFT algorithm, that is scale invariant feature transform algorithm. The log ratio image is generated, and for the generated image the shift feature points were extracted. Regions around the detected points were segmented based on O2 thresholding process. The segmented regions were then compared and performance is measured. The satellite images that were taken in a particular location within particular year limit were selected. The input images were fused based on log ratio calculation. Shift points were extracted for the log ratio image. The regions around the shift points were compared based on that the changes in the images were identified. The segmented regions in both of the images were compared. The resulting change direction map is then used for the identification of the changed regions in the images. The edges of the detected region is much clearer than in the difference image, which is due to the exact segmentation of the regions around the detected key points. The process has reduced iterations and algorithm complexity, which is due to the lack of clustering process, which is generally iterative. The regions around each detected shift points in the images were selected. The segmentation process is based on O2 thresholding process. In O2's method, the threshold that minimizes the intra-class variance is searched. The threshold is defined as the weighted sum of the process, and it is measured with the help of the performance matrices like false positives, false negatives, and the percentage of classification. Let me see the flow diagram of the process. First, the input SAR images were obtained from the dataset. These images were the images of the same portion which is taken in different times. So this is the image taken at time t1, and this is the image which is taken at time t2. These two images were first fused based on the log ratio calculation, from which we extract the log ratio image. The shift points were calculated for the input log ratio image, which detects the exact edge regions of the input images. Based on the identified shift points for the first image and the second image, the ROC regions were extracted. The ROC regions indicates the specific regions which is present around the particular key point, shift key point. The particular regions were then segmented based on O2 thresholding process. The final resulting segment image denotes as the changes in the input images. By comparing the segmented regions of both the images, we identify the locations where the changes have been occurred in the input image. The region in which the changes have been occurred were denoted in particular representation and the others were denoted in a particular representation. This gives the change detection map for the input images. The final image depicts the regions in which changes have measured. Finally, we measure the performance of the process with the help of the calculation of the false positives, false negatives, and the overall percentage of correct classification of the input resulting segmentation process. Let me see the running procedure of the process. If you want to run the code, select the file main.m which is present in the source code folder. Right click it and click on run file. The process will get executed. The first step is the selection of the T1 image, that is the image extracted at time T1. So we select any one of the input image. So after that we obtain the image which is obtained at the time T2. So this is the input image that we have selected, and we have to select the image which is the same as it is. So we have to select this image only. So we are selecting this image. After that the process. So this is the input satellite image obtained at time T1 and this is the input satellite image obtained at time T2. By comparing these two, we obtain the regions where the changes have been occurred. So this is the log ratio image which is calculated. So after the next step is the extraction of the key points. As we can see, we have extracted the key points over the log ratio image. So the regions around each of the key points has to be selected from image 1 and image 2. The each regions which is selected around the key points were segmented based on O2 thresholding for image 1 and image 2. From these two, we identify the regions that were all commonly detected as changes. From that, we can construct a change detection map for the input image. So this is the change detected in the input, change detected in the regions in the input image. Finally, we apply this to the image so that we can particularly identify in which places the changes have been occurred. So as we can see, in these regions the changes have been detected. Finally, we have measured the performances based on the performance matrices. So this is the percentage of changes obtained in the input image, and this is the false positive rate and the false negative rate, and this is the percentage of correct classification. Thus, we have taken the two images of the same location which is obtained at different time as input, and we have identified the changes detected in the images based on unsupervised method for like key point detection based on SIFT algorithm, and we have measured the performances of the process. Thank you.